Oh my gosh, Jeremiah. You're right. And I hope I never ever do know how that feels. So we're continuing our factoring review. This is such an enjoyable class. This is so different from last year online because you guys all, like, I don't see any of you. You don't have your cameras on, but at least you all participate in the class. And boy, does it make a difference. When I talked to you on Monday, we started our factoring review and we did things like greatest common factors, which I won't get into right now. But we were talking about specifically factoring trinomials, right? And trinomials of the variety ax squared plus bx plus c, right? And we that day were specifically talking about where a is equal to 1, which means that we didn't have anything written in front of that x squared. All of our problems started out as x squared, right? And I gave you a little chart that I'm going to rewrite here because it is the handiest chart in the world. I don't know if any of you guys started the homework worksheet. Some of you did, some of you finished it. Wrong, by the way. But this chart, I think, really comes in handy if you're looking at the problems. Because if you have something that is positive bx, positive c, your factors are going to be positive, right? You would wind up with factors that look like x plus something times x plus something else. If you had ax squared minus bx plus c, your factors would be x minus something times x minus something else. Then we had that ax squared plus bx minus c, and we had ax squared minus bx minus c. And on both of those, you're going to have an x plus factor and you're going to have an x minus factor. And if you think about how we multiply binomials together, binomials are these little groupings right here, you would understand why for the c we'd have to have, for a negative c, we'd have to have a positive and a negative factor. And I'll go over that in a minute. Notice I wrote both of these are going to have the same factor. We determine which factor goes where by what's in front of b. So if b is positive, our big factor is positive. If b is negative, our big factor is negative. Does that make sense a little bit? Okay. And if you think about factors, here, I'll just make one up. If I have x plus 2 times x minus 3, and I was going to multiply these out, notice I have a positive and a negative. The only way to get a negative c term when we're multiplying these factors together is to have one negative. If I had two negatives, if we look at this, right? If I look at this multiplication, I'd go x times x is x squared. And then I'm going to multiply x times negative 3, and I get negative 3x. And then I would do 2 times x, gives me plus 2x. And then I'd go, this is the part that counts. We'll do it in a different color so that you remember. Our c term is dictated by this right here, 2 times negative 3. Those two n terms multiplied together give us this c term. And the only way to get a negative one is if one is positive and one is negative, right? If I multiplied two positives together, something weird just happened in the chat box on my screen. Did it happen on yours too? Like, did your chat box get weird?
Yeah, I was doing that.
Jacob, stop that. If these are both positive, the whole thing's going to, this c term's going to be positive, right? Because I'd be multiplying 2 times positive 3, I'd get 6. If this was negative, I'd have negative 2 times negative 3, which would also be a positive 6, right? So the only way to have a negative C term is if I have a positive and a negative factor. And if I multiply these, when I combine this, I get minus x minus 6, and that's what we would get. I just had to complete it. I couldn't not combine those like terms. It's like an OCD for math teachers right there, to leave that incomplete. So the main thing that you want from this is this chart, right? That is the best thing ever. So we did some factoring where a was equal to 1. There was nothing in front of the x squared. Now we are going to do it when we have something other than 1 in front of that x squared. So we're going to do some sample problems, because I think that's the best way to learn, is to just watch problems getting solved. So for example, if I have 2x squared minus 15x plus 18. I'm getting ready to turn the chat off for you guys right now, because y'all aren't paying attention. You're too busy in the chat box. So let's look at one without the x, so that you can see that, so I can show you what's different about it. The last week when we were doing this, say we had x squared minus 15x plus 26, right? We were taking the factors of 26 that would add up to negative 15. We know by the chart that we would have an x minus something times an x minus something else. And the way we found out what those somethings were is we found the factors of 26 that added up to 15. And conveniently, the factors of 26 are really easy. They're 1 times 26, and they are 2 times 13. And 2 plus 13 equals 15. So these are going to be our factors, right? And we would just write them in here. When we're starting with an a that's something other than 1, in this case, we've got a 2 here, it's a little bit different, right? Because we can't just take the factors of 18 anymore. And some of you guys learned stuff like in Algebra 1 or 8th grade math, where you did a thing like this and put stuff in here and stuff in here and stuff. I never know how to do it. I can't do it that way. If you learned that way, it is absolutely fine to use it. I don't like it that way. I like this way because it's just like factoring these, only with one other step. Well, technically 2 other steps, because you have to do it and then at the end undo it. So the first thing that I would do in this situation is I would take this 2 and multiply it to the 18. And I would rewrite the problem as x squared minus 15x plus 36. We're going to put that 2 back in at the end, right? But for right now, we're going to deal with it like it's a problem that has an a of equal 1. And we are going to take our factors of 36. What are our factors going to look like? Well, we have a positive n and we have a negative b, right? Like our c term is positive, our b term is negative. We can go back to the chart and go, well, look, here I have a negative and here I have a positive. So I know I'm going to have 2 negative factors, right? I'm going to have x minus something times x minus something else, right? That something else is going to come from the 36. I'm going to look at my factors of 36 that add up to 15. Our factors of 36 are 1 and 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, and then we're done. That's all the factors of 36. These add to 37. These add to 20. These add to 15. These add to 13. These add to 12. Well, we need factors that add to 15, so they're going to be 3 and 12, right? We're going to put that in here. Here's where it gets a little different. We multiplied this 2 over here. So we are going to have to divide that 2 back out. If it doesn't divide evenly, like when I reduce the fraction, if it doesn't divide evenly, we're just going to move the denominator in front of the x. So this would become 2x minus 3. 12 divided by 2 is 6. So that one divides evenly. So we're just left with x minus 6. Does that make a little bit of sense? I got a C. That means yes. But I only got one of them. I got 2. I got 2 yeses. I got 3 because I got Shaylin over here who's nodding too. We're going to look at a couple more. This time I'll kind of write the instructions along the side so that you can see the steps. And then we're going to jump into difference of squares, and then we'll be done. Difference of squares is super easy. It's like the easiest thing in the world to learn. It's like just one of those little hacks. It's like a hack. That's what difference of squares is. So let's do, I don't want to do that one because that number is going to be huge. I want one with a smaller number. Okay, I like this one. So let's do, for example, 12x squared plus 5x minus 2. So we are going to start by multiplying our A times our C, right? And rewrite the problem. I can't even write in English today, which is bad because it's the only language I usually can write in. So we're going to multiply our A times our C. So we're going to go 12 times negative 2. And then we're going to rewrite the problem. We're going to go x squared plus 5x. Negative 2 times 12 is negative 24. So here, we are now going to figure out what our factors are, right? We're going to have something plus something. We're going to have something minus, because that is always the case when there's a negative C term, right? We're going to take the factors of our new C term. Take factors of new C term. Take that add to B. What does that look like? I don't know. I'm just guessing. I'm just making this up as I go. There's really no rhyme to my math. So here's our C term. Our C term is negative 24. We know we have a positive one. We know we have a negative one. The big one is going to be positive because this 5 here is positive. This B is positive. So the bigger term is going to have to be positive because when I add them together, if the negative term was bigger, we would get a negative number, right? But if the positive term is bigger, we're going to get a positive number. So this determines which factor gets the negative and which factor gets the positive. If it's positive, the bigger factor is positive. So this would be negative 1 times 24. Negative 2 times 12. negative 3 times 8, negative 4 times 6, and that is all the factors of 24. I am going to look at this and go, well, which ones add up to 5? If I add these two together, I get 23. If I add these two together, I get 10. If I add these two together, ooh, looky there, I get 5. Do you see that? And so here where my negative is, I'm going to plug in a 3. And here where my positive is, I'm going to plug in an 8. But I am not done yet. Now I'm going to have to put that 2 back in, or I should say divide it back out, right? I multiplied it. Now I have to divide the 2 back out. So I'm going to divide that A term that we had back out of the factors. What does that look like? I'm going to show you. So here, I'm going to divide this by 2, and I'm going to divide this by 2. Well, 8 divided by 2 is 4, so this one just works, right? X plus 4. But 3 can't be divided by 2. Well, it can be, but it stays a fraction. It's being divided by 2 right there. But since it doesn't divide evenly, I'm going to put that 2 in front of the x, and I will wind up with 2x minus 3. These are our factors. This is our solution, right? Technically, I mean, they're just factors. And if you wanted to test them, you could. You can always test these factors because all factors are saying something's multiplied by something else, right? To equal what we originally had. So if I multiplied x plus 4 times 2x minus 3, I better wind up with our original problem, which was 12x squared plus 5x minus 2, right? And let's see if that's what happens. Here, I go x times 2x gives me 2x squared, right? And then I've got x times negative 3. Well, that is negative 3x. I've outplayed my x. I've multiplied it times everything in the other binomial. And so now I'm going to start with the 4. I'm going to multiply the 4 times each piece. So I've got 4 times 2x. Well, that gives me plus 8x. I have 4 times negative 3. Well, that gives me negative 12. And now we have to just combine these like terms in the center, right? So I wind up with 2x squared. Negative 3 plus 5 is plus 5x minus 12, right? Took us back to our original equation. Did it? No, it did not. What did I do wrong? 2x minus 3. Did I do something wrong? Oh, okay. I feel like I did something wrong there. 2x squared. Oh, okay. Yeah, this was 12. Okay, I see what I did. Because when I multiplied 4 times 2 times, what did I do? 2x. Where did I screw it up?
The x plus the 8.
Oh, I divided by 2 instead of 12. I thought I'd multiply. That was my bad. I should have looked at the beginning problem. Do you see where she found my problem? The original problem is I multiplied by 12. I didn't multiply by 2. So I need to divide out by 12. Right? That was ugly. I hate it when I leave them ugly like that. I hate it. I'm going to erase this part right here. I just wanted my eraser. I should have just turned the pencil around. just so I have some room to show you where I screwed up. I hate it when I screw up. I hate it when I screw up on video too. Oh, that's the worst. Here is my problem. I made my issue up here, not in the checking it. I checked it right. My issue is in my solution itself because we didn't multiply by 2. We multiplied by 12, so I had to divide by 12. I'm going to stop using my eraser here and start using my pen because I feel like I'm making it worse. Right? So here, when I had this x plus 8 times x minus 3, that original one, and I went to divide back in, we didn't multiply by 2 originally. We multiplied to the 2. We took the 12 is what we moved over. So I was supposed to be dividing by 12. This is my bad. I hate that. That's ugly. I hate it when I do ugly math. Here, when I reduce this fraction, I get x equals 2/3, right? Because they're each divisible by 4. Sorry, x plus 2/3. Here, I'm going to get x equal minus 1/4. I just reduced these fractions. That's all I did. Technically, you could leave it like this if you were solving, like if you were setting them equal to 0 and you wanted fractions in there. But the neat, clean way would be to take this 3 and put it in front of the x so that we would have 3x plus 2. And here we would take the 4 and put it in front of the x, and we would have 4x minus 1. And when we went to check the math, we would wind up with the same equation again. Oh my gosh, that's so ugly. I hate that I did that. My apologies right off the bat on that one. It's because I did a different question than I did in the last class, but I didn't want 120 to find the factors of 120 this time. So I chose a different problem and then I screwed it up. Did I confuse you guys enough? Are you guys confused enough? Do you want to see another one of those problems, or do you want me to move on to difference of squares? I'm happy to do either because I would rather do that. I think what I'll do, though, is I'll record this again in my class tomorrow to make the video cleaner.
Can we see one more?
Yes, absolutely. So we have, what if we have 3h squared minus 19h minus 40? Right? We'll move this up to the top. We're going to go ahead and we're going to multiply 3 times negative 40, and we're going to have h squared minus 19h minus 120. And so we know with this one, when we do the factors, we're going to have an h plus something. We're going to have an h minus something. Our bigger factor will be negative because of right here. That's negative, so we know we're going to have a bigger negative factor. I'm going to take my factors of 120. I'm going to go, okay, well, my big factor is negative, so I'm going to have 1 times negative 120. I'm going to have 2 times negative 60, right? I'm going to have 3 times negative 40, 4 times negative 30. And we're going to keep going until we get to the one that works, which I believe is the next one. I think it's 5 times negative 24. 24 times 5 is 120. So this works, right? Because 24 minus 24 plus 5 also gives me negative 19. If we look at these, I could keep going. There's more factors of 120, but I know that this one works, and I don't want to list every factor of 120. But if I go 5 minus 24, I get negative 19, and that is what I'm looking for in my B term, right? So I know I found the factors that will work. And I am going to put them in here. This one, the positive one is going to be my 5. The negative one is going to be my 24. But we're not there yet because we multiplied everything by 3. And it is good to specifically note that, as we learned the last time, that is what we multiplied by. because it'll make our lives easier. So now we have to divide that 3 out. Now in this case, 5 divided by 3 does not divide evenly. So we're going to take that 3 and put it in front of the h. So we wind up with 3h plus 5. 24 divided by 3, though, is just 8. So we will write it as h minus 8. And these are our factors. And if we wanted to check those, which we will this time just to show you this thing complete through and checked, I'm not asking you to check these in your work. I just want you to understand how you can. So here we would go 3h times h, and we'd get 3h squared. And we go 3h times negative 8, and we get negative 24h. We've played out the 3h, so we're moving over to 5, and we'd have 5 times h is plus 5h. And then we'd have 5 times negative 8, which is negative 40. And then when we combine these like terms here, we would wind up with 3h squared minus 19h minus 40, which takes us back. Sorry, I said 3 and wrote 2. Takes us right back to our original problem. And factors, when you multiply them back together, should always take you back to your original problem, right? I mean, if you think about factors in general, that's kind of what they do. Like if I had 6 and I took all the factors of 6, right? I'd have 1 times 6 makes 6, 2 times 3 makes 6. Those are all my factors of 3. When I multiply these two factors back together, I better still get 6, right? Or they're not factors. So even when we're talking about trinomials, it works the same way. If we're finding the factors of those trinomials, when we multiply them back together, it should take us back to our original equation, right? That makes some sense, does it not? So that is it for this part, but we do have this special pattern that we call a difference of squares. It is super handy. It takes so much work out of things. The difference of squares basically says that if I have a perfect square, say we'll call it a squared, minus another perfect square, its factors are going to be the square root of the first one minus the square root of the second one times the square root of the first one plus the square root of the second one. It only works when this is a perfect square and this is a perfect square and they're being subtracted. Difference always means subtraction. So an example of this would be, say I have x squared minus 4. Well, x squared is a perfect square. It's x times x. We're literally saying that we have x and we're squaring it, right? 4 is a perfect square. It's 2 times 2. So technically what we're saying is we have 2 and we're squaring it, right? So I can write the factors of this as x plus 2 times x minus 2. Saves so much work, right? What if I have y squared minus 81? Well, y squared is a perfect square, right? It's y times y. So we know that it is literally y squared. Variables are really easy. They tell you when they're squared. 81, well, that's 9 times 9. And so we could write the factors of this as y plus 9 times y minus 9. Sometimes they can get a little crazy, but they're still not. As long as they're a perfect square on both ends, we could still do it. Say I have multiple pieces, right? What if I have 9x squared? I like this one because it's got weirdness in it. Minus 25y to the 4th. These are both perfect squares. This is 3x squared minus 5y squared squared. Crazy, right? Because y to the fourth is just y squared times y squared. So my factors on this would be 3x plus 5y squared times 3x minus 5y squared. Let's look at another one. I want you to see as many, because they go really fast, so we can always show plenty of them. What if I have, let's do a different color so that we can see it's a different problem. What if I have m squared times n squared minus 49? Well, each of these are squares, so we know it's a perfect square. It's like saying m times n squared. 49 is 7 times 7, so that is ultimately 7 squared, right? So we could write our factors here as mn plus 7 times mn minus 7. Sometimes they'll try and trick you a little bit with difference of squares. But remember, with these problems, we're always supposed to look for a greatest common factor first to pull out. So if I have, this will be the most complex one that you would see, is what if I have 2a squared b minus 32 a to the fourth b. Well, they each have a b that's not squared, but these are each also divisible by 2. And technically, we're always supposed to look for that greatest common factor first, like we did earlier this week. So I'm going to start by dividing each of these by 2. Like I know each of them, I can pull out a 2. And this one has an a squared, but I'm going to leave that for right now. I'm going to leave my a's alone, but b's don't have any square at all, right? So I'm going to pull out 2b. And that is going to leave me with, if I take the 2 and the b out of here, I'm left with just the a squared. Minus, well, 32 divided by 2 is 16. And I'm going to have my a to the fourth. And that's it, right? Now, I could pull that a squared out, can I? They each have an a squared component. Could I pull that out? I can. This is still 2 perfect squares, but even if I pulled that a squared out, if I wrote this as 2a squared b, and I pulled that out, I'd be left with 1 minus 16a squared. This is still a difference of squares, right? 1 is a perfect square. What is 1? 1 times 1, right? 1 cubed, 1 times 1 times 1. 1 to the fourth, 1 times 1 times 1 times 1. So here we've pulled out our greatest common factor. So we would have 2a squared b, and then I would have 1 plus 4a times 1 minus 4a. That'll be as complex as it gets. I am sorry I went all the way to the end of class. I apologize for that. I like to usually give you guys some time, but I'll let you go to English. The worksheet is posted. Please do it. It won't count till the next triad, so if it's late, don't worry about that hurting you, because it won't be on this triad's grade because it's not due until after Friday. But you should be able to do the whole worksheet now. Enjoy your weekend. Thanks for your patience. I'll talk to you later. Yes, at least the bell's working today. I agree. Bye, you guys. Sorry I took up so much time. I mean, I don't know why I'm apologizing for that. I'm supposed to take up that much time, but I just like to give you a little at the end usually.